Welcome back, geometry students, to another Regents review video. This is the Geometry Common Core Regents exam for August 2017 administration. This, again, was a toughie. So, these are going to be the solutions to part 1. These are the multiple choice questions still. Questions 13 through 24 of this exam. Before we begin here, please do not take these answers and put them on a piece of paper to hand this in for homework. I assume that if you're here, you are here to either get assistance that you need desperately, or you're studying for your Regents, but don't come here to just take my answers or to take my work. The answers are online. Just don't take my work unless you work for it. Hit that subscribe button down below and consider becoming a Patreon at patreon.com. The link is in the description below to become a Patreon. If I help you out a little bit, you can help me out a little bit by throwing $1 at me. That'd be helpful. And make sure that you visit my website at www.nysmathreadsprep.com for more math content. Without further ado, let's jump right now to question number 13 of this exam. And we begin with a pretty challenging question, folks. Let's begin. 13 says, a rectangle whose length and width are 10 and 6 respectively is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Okay, which line could the rectangle be rotated around? Now, the key words here that I see very quickly that should be important to you as well is volume is 150 pi and continuously rotated about one of its straight lines. What should be screaming at you in your head is if it's being continuously rotated around a straight line and it is a rectangular 2D shape, you are creating a cylinder. You're creating a cylindrical shape, okay? Because if I spin around one of these sides, you're going to be creating a circular figure, okay? So that's what you should be thinking of right now. The problem is all of these calculations are going to take a little bit. It's asking you which line could the rectangle be rotated given that the volume is 150 pi. Okay, let's take it slow. Let's go through each answer choice. Let's see what the heck they're asking us to do. Let's take a look at choice 1, alongside. Okay, well, alongside in this case is if you were to rotate the rectangle around the long side, as in you're rotating in this direction. You're spinning it like this, okay? So if you were to spin it like this, that means that this is your radius of the cylinder, and this is the height of the cylinder. Unfortunately, it's on its side. So if you were to just imagine stand it upright, you're spinning it around, this is the height, that's your radius, okay? So the volume formula of a cylinder, this is choice 1 by the way, the volume formula of a cylinder is pi r squared times the height. So in this case, the radius is 6, so we have pi times 6 squared times the height of 10, okay? Ignoring the pi for a second, let's just multiply the numbers. 6 squared is 36, so this is pi times 36 times 10. This, ladies and gentlemen, will yield an answer of 360 pi. So, unfortunately, the long side cannot work because it's asking you for a volume of 150 pi. You see how this is working so far? Let's keep going with this, and let's see what we could get. Let's take a look at choice 2, a short side. Okay, go to a short side. This is your height this time. It's now spinning around the short side, and this is the radius. So really, you're spinning it in this direction, okay? So, volume equals pi r squared times the height. That will give you pi. The radius is 10, square it, times the height of 6. That will give you pi times 100 times 6. That will give you an answer of 600 pi. That is not 150 pi, so that can't work. Now, let's take a look at choice 3. The vertical line of symmetry. Okay, this is tricky. the vertical line of symmetry is here. You're spinning it around like this. This 6, without a question or without a doubt in your mind, is the height. The problem is, what is the radius? The radius is not 10, it's 5. Because what we just did is we just bisected this side down here to get a length of 5 and 5. This is your radius. The 5, not the 10. So because we're spinning it around, basically we just have two actually, the perfect example of the revolving door. If you take two rectangles and it has a central axis, this in this case is the central axis of the spinning doors, and you just spin it around, that's why the radius is 5, not 10. So let's go ahead and calculate it. So number 3, again, v equals pi r squared times the height. This will give you pi. The radius is 5. The height is 6. This will give you pi times 25 times 6. 25 times 6 is 150. Smack on the pi. And ladies and gentlemen, that is your answer. The vertical line of symmetry would be correct. And if you just wanted to know the calculation for choice 4 would result in an answer of 90 pi. So that can't work either. All right, so your answer is choice 3. In my opinion, that was a pretty challenging multiple choice question. Number 14. If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? We're talking about a rhombus. We're asking for the specific property of the rhombus. Well, a couple things about the rhombus. The diagonals are perpendicular. Actually, let me make some room here. Rhombus. Let's come over here. A couple things that are special about the rhombus. Diagonals are perpendicular. Okay. What else? Diagonals bisect the angles from which they are drawn. And what else? All 4 sides are congruent. That's pretty important stuff. So now, using all this information, let's go ahead and draw ourselves a rhombus. Okay? Lucky me, I have the tools on my computer. Sweet. Rhombus. Okay. I'm going to label this as A, B, C, and D. Make sure it's just in a clockwise or counterclockwise fashion. You can't be skipping vertices around. So it says here that the measure of angle ABC is congruent to the measure of angle CDA. While that is true in a rhombus, that opposite angles are congruent, that is the property of a parallelogram, not the property of a rhombus. Even though that the rhombus has a property, we're looking for the specific property that proves a rhombus. So choice 1 is out. Choice 2 says AC. Okay, so the diagonal. So AC is congruent to BD. Absolutely, positively, no. This is the property of a rectangle. Rhombi do not have congruent diagonals, so that doesn't make any sense. Choice 3. Diagonal AC is perpendicular to diagonal BD to create right angles. Oh, wait a minute. Didn't I just say before that diagonals are perpendicular as a special property of a rhombus? You bet I did. Your answer is choice 3. No questions asked. That is the answer. All right, moving along. 15. Ooh, sweet. Triangle. To build a handicap access ramp, the building code states that for every 1 inch of vertical rise in the height, the ramp must extend out 12 inches horizontally as shown in the diagram below. What is the angle of inclination, x, of this ramp to the nearest hundredth of a degree? So, they're asking you to solve for this. This is a classic SOHCAHTOA question. Okay? So what you need to figure out is if I were to draw a little stick figure here, I call him Pablo. I think Pablo's a cool name. If you draw him there and you take a look and see, wait a minute, that's across from me, so that's your opposite side. And the 12 is next to, that is your adjacent side. If you're using an O and an A, you're using tangent, TOA. So we need to use tangent. So The standard form of this would be tangent of x, angle x in this case, would be equal to the opposite over the adjacent. Okay, we need to find angle x. So the tangent of x is equal to the opposite side, which is 1, over the adjacent, which is the number 12. The problem is, what do we do from here? In order to solve for angle measures, you have to use the key on your calculator called tan inverse. Many of you call it tan -1. It's actually called tan inverse. Doesn't really matter to me personally, but it's called tan inverse. So we're taking the tan inverse of the function that we're doing, which is 1 over 12, or the ratio, I should say. So go to your calculator, use the TI Inspire, make sure it's in degree mode. Click on tan inverse of 1/12. And if you're using the TI 83 or 84, it should be second tan. Enter, we get 4.76. 4.76, your answer is choice 1. Pretty simple stuff, basic trigonometry question. It's on every Regents. Make sure you know how to do it. All right, moving on to number 16. Okay, 16 says, in the diagram below of triangle ABC, DE and F are midpoints of AB, BC, and CA, respectively. So F is a midpoint, E is a midpoint, D is a midpoint. Okay, that means that this is congruent to this is congruent to this, and this is congruent to this. What is the ratio of the area of triangle CFE to the area of triangle CAB? So they're asking you, what is this area of the triangle in relation to this area of the triangle? So what you need to know is that a midpoint divides a segment into 2 congruent parts. So it doesn't matter what these lengths are. This could be 5, it could be 7, it could be 1,000,000. I don't care what that side is, but this is the same. So let's just pick numbers. This is 5, this is 5. Let's just pick 6. That's 6, that's 6. Let's say this is 4 and 4. Okay? Look at what's going on here, folks. By the way, if AD is 6, then FE is 6 as well. Look at the area of this triangle and look at the area of this triangle. You notice how if we add these sides together, it's double the length of all of these, okay? The relationship, what I'm trying to get at here, the relationship between a small triangle and a big triangle that have 2 congruent parts, because really, here's the thing. Triangle CAB is doubled, or is double triangle CEF, okay? So if it's doubled, that is your scale factor. The scale factor in this case is 2. Okay. So what are you trying to say here, Trevor? Let me tell you. The relationship between the area is always the scale factor squared. So what I mean here is that the relationship between the yellow triangle, which is, I'm going to call that a relationship of 1. The relationship between the yellow to the green is a ratio of 1 to 4, which is choice 4. And if you still don't understand that, I'm trying to think of a better way to explain this. All you need to know is that the scale factor is 2. And if you're trying to find the area, that is always equaled the scale factor squared. If you're trying to find the perimeter, it's always the perimeter of the small triangle times the scale factor. If you're looking for the volume, it is the volume of the small, it's the volume of the dilation scale factor cube it. You see how that makes sense? So area is always in square units, volume is always in cubic units, perimeter is just in basic units. So the area is the scale factor of 2, and you just square it, because in this case we could be in square feet, square inches, square anything. So that's why it's going to be choice 4, a ratio of 1 to 4. If you do have any questions on that, please shoot me an email or put in the comments below. I know that's a confusing question. Number 17. All right, the coordinates of the endpoints of AB are -8, -2, and 16, 6. Point P is on line AB. What are the coordinates of P such that AP to PB is 3 to 5? Again, if you've seen enough of my videos, you know that I teach this very differently than most teachers. I don't care the way you do it. As long as you get the right answer, it's good for you. You need to find the X value, and you need to find the Y value of point P. The formulas that you need to know in order to get this question right is X minus X1 over X2 minus X is equal to the given ratio. And the y value is y minus y1 over y2 minus y is equal to the given ratio. Okay, so the given ratio is actually 3/5. That's if you put it as a fraction. Your a comes first. You see how the a comes first? That means that your coordinate a immediately becomes x1 and y1. If you make point B x2, y2, if you make point B x1, y1, you're going to get it wrong. This has to be x2, y2 because point B comes last. So let's go and plug this information in. So we get x minus a negative 8, watch your signs, over 16 minus x equals the given ratio of 3/5. What I'm now going to do is I'm going to cross multiply. So we get 5 times x plus 8 equals 3 times 16 minus x. Distribute the 5, distribute the 3. We get 5x plus 40 equals, what is 16 times 3? I'm drawing a blank. I knew that. 48. 48 minus 3x. Add the 3x on both sides. We get 8x equals, 8x plus 40. I shouldn't have said equals. 8x plus 40 equals 48. Subtract the 40 on both sides. We get 8x equals 8. Divide by the 8 on both sides, and you get x equals 1. So that knocks it down to, it's choice 1, people. Let me just show you to get the y values, and you'll be good to go. So y plus 2. Well, it's y minus a negative 2, but I know it will become positive later. Just simplify that. Over 6 minus y equals a given ratio of 3/5. So we get 5 times y plus 2 equals 3 times 6 minus y. Distribute that 5, distribute the 3. You get 5y plus 10 equals 18 minus 3y. Add the 3y on both sides. We get 8y. We're going to subtract that 10 too. We get, is that 8 as well? Yes, it is. Divide by 8 on both sides. And we get y equals the number 1 once again. And your answer is still choice 1. Okay, that's it. That's how you do that question. My way, you could do it any other way as long as you get the answer right. I don't really care how you do it. But that, in my opinion, is probably the simplest way to do it. Not graphing. Graphing's a pain in the neck. Number 18. Christy is testing values that would make triangle KLM a right triangle when LN is an altitude and KM equals 16 as shown below. Which lengths would make triangle KLM a right triangle? Okay, so here's the thing. She wants LN as an altitude. The minute you see altitude in a right triangle proportion and you see a base, you should be thinking of the following acronyms. You should be thinking of HILS, which stands for hypotenuse over leg equals leg over segment. I teach it personally as part over segment equals segment over whole called Passois. So you're using one of these two. Which one are you using? Well, actually, they're both the same thing. My apologies. They're both the same thing. Hills and Passois mean the same thing. I teach it as this way. Some teachers teach it as hills. Whatever you got to do. She wants that as an altitude. Okay, so we're given these answer choices. So LM is 13. So let's plug in 13. And KN is 6. Okay, so that would make this NM, that would be the number 10. Just by taking 16 minus 6 gives you 10. So in this case, we need to make sure that it is in the right proportion. Let's talk about this. If I were to use the Hills or the Passois method, let's use part over segment equals segment over whole. So your part is the 10, your segment is the 13, which the segment is always by itself, like away from everything else, equals 13 over the hypotenuse, or the whole thing in this case, which is 16. Is 10 over 13 equal to 13 over 16? Well, if you type it into your calculator, you're going to see very quickly that it does not. See how it says false on your calculator on the TI Inspire? These fractions are not equal. Therefore, that cannot be an answer. Let's take a look at choice 2. Choice 2 says LM is 12 and NM is 9. That would make this over here, that would make this, what would that be? 9, 8, 7, 6. NM is that, yeah, that would make that 6. So, no, I'm sorry, 7. I'll make that 7. So, NM. Okay, so what we need to make sure about is, would this be a proper proportion? Okay, so part over segment equals segment over whole. Is 9 over 12 equal to 12 over 16? Okay, that is a Passois method. The Hills method stands for hypotenuse, which is 16 over the leg equals the leg over the segment. Pretty much the same. It's the same thing on both sides of the equal sign. So 9/12, when you reduce that in simplest form, that's 3/4. 12/16, that's also equal to 3/4. Hey, wait a minute. Those are the same fraction. Choice 2 is the answer. If you look at the other one, over here, it's pretty much the same thing. This is just 4/3 equals 4/3. Same fraction. It works. Your answer is choice 2. Okay? Just know how to do your triangle proportions, and you are good to go. Number 19. In right triangle ABC, the measure of angle A is 32. The measure of angle B is 90. AC is 6.2. What is the length of BC to the nearest tenth of a centimeter? Draw yourself a triangle. Enough said. A, B, C. 90 degrees. Angle A is 32. AC, which is hypotenuse, is 6.2. We're trying to solve for the length of BC. That's your X. We're using SOHCAHTOA because you know that we're using SOHCAHTOA since we are only given one side length and we're given an angle measure. We need to solve for one of the other sides. We have to use trigonometry. We can't use the Pythagorean theorem here. So this is my reference angle. Again, here's your little stick figure. Here's Pablo. This is your opposite side. And this is your hypotenuse. Well, we have an O and an H. We're using sine. So the sine of 32 degrees is equal to the opposite side, which is X, over the hypotenuse, which is 6.2. From here, you just cross multiply and solve. So it's 6.2 times the sine of 32 equals X. Let's go ahead and plug that into our calculator. 6.2 times the sine of 32. That will yield a result of 3.3. Yes, that's when you round it to the nearest tenth. So 3.3. So X is approximately equal to 3.3. Your answer is choice 1 for that question. Moving on to number 20. This one was a doozy. This one was like, what is going on here? So let me move this over. 20 says, in 2000, the 2010 U.S. Census populations and population densities are shown in the table below. Based on the table above, which list has the state's areas in square miles in order from largest to smallest? So what you need to know, and I know that this is a wacko formula, you've probably never even seen it before, but population density, they tell us, is population over area. They kind of tell us right there. It's people over miles squared. People is population, area is miles squared. Notice the square on that. That means area. Again, just to let you know. Now the area, because it's asking you, has the state's areas from large to small. You're trying to find the area formula. What's the area formula? Well, you need to get A up here expressed in terms of the population density and the population. So the area formula is the population divided by the population density. And that's simply by isolating the A, or the area, in terms of this equation up here. So this is the formula that we need badly. So let's take a look here. Let's calculate the population, let's calculate the area of all the states. Let's calculate the area for Florida, okay? The population in Florida is that many people, and this is the population density. I'm going to plug that into my calculator. So we get 18,800,000. Well, these are some wacko calculations. 801,310 divided by 350.6. That yields an answer of 53,626. 53,626. Okay, let's go ahead and try Illinois. Okay, so that right there, when we plug everything into our calculator, let's see, 12,830,632 divided by 231.1. 55519. 55519. Okay, that's Illinois. Now let's find New York. New York is probably a lot less just because it's so freaking populated. But we'll take a look. Where's my calculator? There it is. Okay. So we got 19,378. I thought that there was more. Oh, that's 2010. Yeah, there's definitely a lot more people in New York now. Divided by 411.2. That is going to be 47,126 if you round it up. 47,126. 47,126. And Pennsylvania, the great state of Pennsylvania. That's where Hershey Park is. My favorite park in the world, Hershey Park. If you haven't gone, make sure you go. There's a lot of chocolate there, lots of rides, lots of attractions. Pretty fun place to go to. It is my second favorite destination behind Disney World. 79 divided by 283.9. 44742. 44712. I just calculated all those areas. Now we need to find which one is from the largest to the smallest. Well, the largest is Illinois. The smallest is Pennsylvania. The largest is Illinois. There's that one. The smallest is Pennsylvania. Florida follows, then followed by New York. Boom. Choice 1 is your answer. That was certainly a tough question, folks. Choice 1's your answer. Number 21. In a right triangle, the sine of 40 minus x equals the cosine of 3x. What is the value of x? So you need to know this fact. Pretty important fact. If you don't know it yet, I suggest that you learn it. Sine and cosine are cofunctions which are complementary. Complementary, if you don't know what that means, complementary means 90 degrees. So what you need to do is you actually just need to, it's very simple. Take the inside pieces of your sine and your cosine, add them together, and set it equal to 90 degrees. I'm not going to get into the specifics of why that is. I could go through a whole long proof. Basically, if you just plug in any value of x that makes the sum of those two numbers add to give you 90, the sine of whatever that number is inside is equal to the cosine of its complement. Okay? So let's go ahead and find the value of x. Actually, once we find the value of x, I'll prove it to you. Here we go. So we get 40 plus 2x. Just take the negative x and add it to the 3x. You get 2x equals 90. Subtract the 40 on both sides. All right, we get 2x equals 50. Divide by the 2 on both sides, and we get x is equal to 25. That is your answer, folks. Let's make sure it is. If we take 25 and we plug it into both of these expressions, we get the sine of 40 minus 25, which is, what is that, 15? 15, yes. So the sine of 15 is equal to the cosine of 75, okay? Is that true? When we take 25 and we plug it in, okay? If we go to our calculator and we type in the sine of 15, does the sine of 15 equal the cosine of 75? Hey, they tell you it's true because, again, sine and cosine are cofunctions which are complementary. Your answer is choice 4. All right, moving on to 22. This is a repeat question from like in August, I want to say 2016 exam. This came up a second time. I was pretty surprised. Yeah. No, wasn't this on the, you know what? I don't know. It was definitely on a recent exam. 22 says a regular decagon. Decagon has 10 sides, by the way. Make sure you know that. 10 sides. Is rotated n degrees about its center, carrying the decagon onto itself. The value of n could be what? So you need to know the formula 360 degrees divided by the number of sides equals the rotation. Okay? So what I'm going to do is this. I'm going to take 360 degrees, divided by the number of sides, which is 10. That gives you a result of 36 degrees. Ladies and gentlemen, the number of degrees that would map the decagon onto itself is 36, but I don't see that answer here. What you need to understand is 36 is just one option. There are actually an infinite amount of n degree of rotations to map the decagon onto itself. What you need to do is take each degree measure and divide it by 36 and see if you get a whole number. That's your goal. See if you get a whole number. Well, if you take 10 divided by 36, that doesn't give you a whole number, that gives you a fraction. That is less than the number 1. That doesn't work. 150 divided by 36. 150 divided by 36. Does that work? No. 25 over 6, that's a fraction. Doesn't make any sense. Let's try 225. 225 divided by 36. No, that's a fraction. That can't work either. We're looking for whole numbers. Let's try 252. 252 divided by 36. What do you know? It's 7. So that means that 252 is a multiple of 36. So 252 is a multiple of 36 degrees. And that's your answer, choice 4. Not a bad question. You just had to know that one basic fact. And I know that was annoying. Okay, 23. In a circle with a diameter of 32, the area of a sector is 512 pi over 3. The measure of the angle of the sector in radians is what? So what you need to know is this fact. Or this formula, I should say. Area equals 1/2 r squared theta. Now, you might be thinking to yourself, Trevor, I thought you told us that the area of a sector is n over 360 pi r squared. It is. It is. But the problem here is they want the answer in terms of radians. In layman's terms, a radian is just another way to express an angle measure. Again, all of this stuff goes back to elementary school. When you were in elementary school, even in high school, in geometry, you're dealing with degree measures. Whenever I say parallel lines, yeah, that's 60 degrees, that's 120 degrees. The problem with that is when you get to higher level math, you need to start expressing things in radians. Radians is actually expressed with the number pi. So this formula here is nice, but this gives you degree measurements. This gives you radian measurements. You see the difference here? So I would rule out this and use this formula instead. So let me get rid of all this garbage. We're using this formula. Area equals 1/2 r squared theta. Okay? The angle of the sector, that is your theta. Theta is just a Greek letter to represent an angle measure. A still means area. R still means radius. That's still standard. Theta just means the angle measure. So they tell us that the area is 512 pi over 3. That equals 1/2. Now the radius, okay, the diameter is 32. That means that the radius is 1/2. The radius is 1/2 of the diameter, which is going to be 16. Square it times theta. So when we simplify this, what do we get? What do you get? 16, let me type this in. 16 squared and divide that by 2. We get 128. So this gives us 512 pi over 3 equals 128 theta. Okay? Divide by 128 on both sides. This is going to be a pretty messy fraction, but we could deal with it in our calculator. It doesn't matter to me. So we take 512. Now here's the thing. The answers are in terms of pi. I'm not going to type in pi. That's just stupid. 512 divided by 3 divided by 128. 4/3. So your answer is theta equals 4/3. Attach on the pi at the end. Your answer is choice 2. And I know that was definitely a different way of doing this question. I would not use n over 360 pi r squared. It just takes a little bit more time. It can work, but then unfortunately you got to go back to your reference sheet, which is all the way up here for me. You got to go back to your reference sheet and convert your degrees to radians by multiplication. I would not recommend it that way. Just too time consuming. Not that time is an issue, but it's just not worth doing it. Okay, now we're moving on to the last question of the multiple choice. Here we go. What is an equation of the perpendicular bisector of the line segment shown in the diagram below? Okay, two words ring out like screaming at me. Perpendicular bisector. Okay. Perpendicular in terms of slopes means negative reciprocal slopes. Okay, that's what that means. A bisector means passing through midpoint. Okay, so what we need to do is find a couple things. We need to calculate the slope of this line, take the negative reciprocal, then we need to calculate the midpoint. Let's take a look. The slope of this line, we could even just eyeball it. It looks like we're going down by 2 and to the right by 1. So the slope of this line is down 2 over 1. That means that the slope of the new line, if we take negative 2 over 1 and we flip and change the sign, that gives us a slope of a half. Okay? We just got our new slope. Now let's calculate the midpoint of this. So the midpoint, even if you just eyeball it, you know that this is the midpoint right in the middle. But let's just say you didn't know that. The midpoint formula is just x1 plus x2 over 2, y1 plus y2 over 2. This point up here, this is the point negative 2, 4. This down here, this is the point 2 comma negative 4. Oops. 2 comma negative 4. Plug in your information. Negative 2 plus 2 over 2, comma 4 plus negative 4 over 2. That gives you 0, 0, and that's exactly where we are. We are at the origin. So the midpoint of the new line, so the midpoint is 0, 0. That is what we need to pass it through. Okay, so let me get rid of all this. It says perpendicular bisector. We just got the slope. We just got a point. Ladies and gentlemen, this formula bothers the crap out of most of you, but you need to use it because it's that easy. You need to use the point slope form of y minus y1 equals m times x minus x1. I know most of you prefer y equals mx plus b, but believe me that when you get to higher level math, when you get to pre-calculus and calculus, if you continue on that high, you will be needing that formula. And it's honestly not that bad. You just take y minus the y1 value. This is y1. The 0 is your x1. And your slope is just right there. So y minus 0 equals 1/2 times x minus 0. So it's really just y equals 1/2 x. The zeros just drop out. So we're looking for y equals 1/2 x. Oh, of course they weren't nice enough to put it in the freaking forms that we wanted to, but that's okay. Let's go through each answer choice. If we take this and put in y equals mx plus b form, subtract the 2x on both sides, this gives you a result of y equals negative 2x. That's not the same thing. If we add the 2x on both sides, this gives you a result of y equals 2x. Not the same thing. This over here, we get 2y equals negative x divided by the 2 on both sides. We get y is equal to negative 1/2 x. That's not the same thing. Let's double check this just to make sure we're right. This is 2y, we add that x, so we get x divided by 2 on both sides. We get y equals 1/2 x. Bingo! Your answer is choice 4, and that is the answer to that question. Not too bad of a question. All right, I hope this helped you. Make sure that you hit that subscribe button down below and visit my website at www.nysmathreadersprep.com, and please consider becoming a Patreon on my Patreon page. That link is in the description below, and I hope to see you soon.